While Columbia sat on the launch pad, the 5 of us were having breakfast and then getting suited up. Here I am waving to the kids. Rommel is just about to go through the pressure check of his launch and entry suit, and that's what Tammy is doing here as well. These suits are not totally uncomfortable, but they're not the kind of thing that you'd like to wear. Here's Tom. For any extended period of time, and getting into and out of them is not real pleasant. So it was nice that we launched on the first day. It would have been, well, it was a reasonable trade to have to get in and out of the suit 2 or 3 times in order to get the extra couple days on orbit.
Launch day was absolutely a beautiful day, something new to me. On my last flight, I climbed in the vehicle several times before we went anywhere. Here the engines are lighting 6 seconds prior to liftoff. The vehicle stack goes through its twang, but when the solids light like this, there's no doubt in your mind you're going somewhere. We had a cadence. Tom started it. He said 102, 102. The computers were in mode 102. I said auto, auto. Pitch and roll yaws were in auto and not CSS. And Taco was supposed to say, there goes the tower. But by the time he could say, there goes the tower had already gone. And we're doing more than 100 miles an hour at that point. Here are the solids. What's interesting, they've got 550 tons of propellant. And they're burning that propellant at the rate of about 5 tons per second. So that explains why they're giving us about 6 million pounds of thrust at this point. At about 150,000 feet, they detach. We're going about 3,000 miles an hour here. And once they detach on the solids, it's a pretty rough, vibrant ride. And then it becomes a very smooth ride from there to orbit.
First order of business after getting to orbit is to convert our rocket ship into a laboratory or a satellite deployment platform in this case. And so we swing open the payload bay doors about an hour and a half after getting to orbit. Taco is working with Rommel to convert the computers over to on-orbit mode while we're getting ready in the back to check out the arm and get the satellite out of the bay.
We grappled the SPA satellite about 3.5 hours into the flight, and some checks were performed both by the crew and the ground. And here we are taking the satellite out of the payload bay and maneuvering to the release position. Tom, of course, is assisting me here with the arm. Everyone in the crew is involved in the rendezvous, in the RMS deploys. But SPAS was a model satellite. The spacecraft performed flawlessly. The group of folks that we worked with in Germany were just incredible to work with, incredibly professional and enjoyable to work with. So we were pleased to be part of the SPAS, the Orpheus SPAS mission. Here we are maneuvering again the SPAS to the release position. Once SPAS is in the release position and our window for release opens, this is the end effector view. We maneuvered the arm, we released the spacecraft, maneuvered the arm away from the SPAS, and then very shortly thereafter, approximately 1 minute, Taco fires some jets on the orbiter so that we would induce a separation velocity between the orbiter and SPAS and send it on its 2-week mission of astronomical observations.
Here we are on the mid-deck, and this is the same secondary I'd mentioned earlier, running the capillary pump loop experiment. And here you can see it, and this is about as exciting as it ever got. But it was a tremendous experiment run by the University of Maryland.
Out in the payload bay, we had the space experiment module, a gas can type experiment with 10 experiments provided by students in high schools and colleges around the country. And they used microgravity to great effect on our 18-day flight. Now here you see the sequence of bringing the wake shield out of the protective cone in the back of the payload bay, protecting the source cells that spray material onto the wafer growth surfaces on the wake side of wake shield. This is, again, flight day 4. And the first place we took the wake shield satellite was over the port side, pointing into the ram direction so that the contamination on the bottom of the shield here would be cleaned off by atomic oxygen in orbit. After a couple of hours during free drift, while we cleaned the wake side of the satellite, we then swung it over to the other side of the payload bay to check out the attitude control system. And so we were doing a constant series of RMS maneuvers with some pauses in between while the shuttle oscillated slowly in free drift, getting ready for the deploy sequence. And here we go over to the other side of the payload bay towards the ADAX checkout, or the attitude system checkout location. You can see the Sahara sweeping by in the background.
As Tom was saying here, we maneuver the arm and study where the wake shield thinks it is in terms of its attitude determination system, and we watch the responses of the satellite to the RMS. After going to the 8-ax deploy, and then we go to a deploy position, Tom has dropped it here, we study the attitude determination and control system, its performance for 1 minute. We did get into a little higher reaction speed here than planned, and as well we had an 8-degree roll excursion, and so the wake shield community wanted to study this response for a few minutes longer. We did observe to watch the clearance with the aft TV cameras. I'm waiting here to start the thrusters. They're coal gas nitrogen thrusters, and here the wake shield is thrusting away from the orbiter. It's a 20-minute burn.
Here are the two satellites in formation with each other. After wake shield has been deployed, they're about 15 or 18 miles apart at that point, and we're going to fly between those two to rendezvous with wake shield. As you can see, we do need to eat on board, but you can define your own kitchen table upside down or not. And we do have to keep things clean. Rommel here is vacuuming one of the filters. It collects a little bit of dust on it. We just vacuum the dust off of it. One of several filters in the payload in the crew compartment.
Here on the aft flight deck, we have all of our TV recording studio set up, 4 separate recorders to record SVS data that Tammy talked about earlier, and all of this data was shipped back to the ground after landing.
We had a number of orbit adjust burns to keep us in the proper position with these two satellites. Some of them were fairly long, as you could see the plume from the exhaust over the nose there. And we use the computers to tell us what to burn, but then we make the burns manually, and you can see how the firing of these little rockets shake the vehicle. You can see the computer on the glare shield sliding around a little bit. What we're looking through there is a little gun sight. We got the reticle turned down fairly dim so that we can see outside well, and wake shield was showing up in the gun sight, and we're flying up closer to it. Again, we manually are flying, and you can see Tammy in the window next to me taking sightings with the police laser. When we get it down over the payload bay, it's time for Tom to go to work and grapple it.
It's remarkable how smoothly our pilots brought this spacecraft into the payload bay envelope. I'd never seen another spacecraft in orbit before, and this one was remarkable in its stability. Taco parked us right underneath it, and then we rotate the RMS end effector, get it into the right orientation for grapple, and then it's just a matter of going and closing the grapple pin and not bumping the satellite out of the way in the process. So here we are closing over the grapple pin with the end effector. We trigger the snares and then bring the wake shield back aboard after its 3 days of material science. Once grappled to the arm, we can bring it back down into the payload bay, and we even used it the next day for some space vision system experiments. Aft flight deck teamwork is very important as we bring it down into the payload bay. We even had space vision system here providing us berthing cues in addition to the usual TV camera and RMS digitals that we use for standard payloads. Wake shield was really a joy to operate on the arm. Tammy's here with one of our long lens telephotos, Hasselblad camera, and we'll show you a few views of the Earth in the movie here too. Notice the glow.
Hygiene's important in space also, so Story was getting a little bit shaggy, so he's getting a little bit of a trim and a polish here. Also, I think you could define our crew as works well together. When we had a noise drink spill, everybody chipped in to help clean that spill up.
As many of you know, Story was making his 6th flight on the U.S. Space Shuttle, and while we were on orbit, he passed over 1,000 hours of time in the Space Shuttle. So we came up with this patch that says Master of Space and presented it to him in a little ceremony on board.
Here we are on the mid-deck the day before the Flight Day 10 scheduled EVA, applying antifog to our helmets and also getting our tools in the proper configuration in anticipation on the for the EVA of the next day. Tom here has the shuttle power tool, and I'm holding the new station power tool that has some enhanced capability, but as you can see is quite a bit larger than the shuttle power tool. We spent several hours getting our tools in the proper configuration and everything laid out to make EVA day go much more smoothly and efficiently. Tom is donning his lower torso assembly, and it's always a bit of a squeeze getting into those pants. And shortly you'll see my head pop out of the upper torso. And Story, of course, was instrumental in getting us suited up and prepared to go out the door. The crew got into the airlock. We depressed the airlock. The RMS got in position to view crew egress. We went to open the hatch. The handle rotated about 35 degrees and came to a hard stop. This happened over and over again, more times than I can count. And unfortunately, we were never able to open the outer airlock hatch, and the EVAs were canceled for the flight.
Well, we wanted to get off on time so that we could get you all home for Thanksgiving, but you can probably blame me on that because this is my third Thanksgiving in space. But here we are eating a traditional turkey. I had flown during Thanksgiving with John Blaha back in '89. I wanted to fly in space again, and I did get to fly with him, but on different vehicles. You all were nice enough to patch us in with him. The moon from out there in space is very similar to the moon down here on Earth. It goes through the same phases, and we watch this moon grow to a totally full moon.
This is a shot of Flight Day 15, and this is the day when we're rendezvousing with Orpheus to bring it back. The Taco was kind enough. We swapped roles during this rendezvous. So I was at the aft station, and Taco was in the forward station until, and now you notice Taco's in the picture, until we got within 100 feet, and then he took it for the prox ops and the grappling.
Rommel and Taco did an outstanding job with the rendezvous. They put the spacecraft very, very steady into the end effector camera. All that was left to do was a quick maneuver and a grapple of the Orpheus spas. Post-grapple, we did do a number of maneuvers in support of some space station experiments, testing our SVS system, and making sure that we could get very good position and attitude information out of the space vision system in order to facilitate some of the space station construction activities. And this is our final berthing of the spas.
Let's take you back outside. We're going to give you some camera views of the Earth. Always in the background as we maneuvered the spacecraft during our long flight. Looking down, we can see some very delicate linear dunes in western Algeria in the great western sand sea of the Sahara. This is a very early morning view. You can see the delicate sculpting of the dunes by the wind. A little bit farther to the east is a big outcropping of black volcanic rock. It's dark gray because of iron and manganese in the rocks. And the Tifernine dunes that are there on the right side, the thumb-shaped dune field, is red because of the iron in the sand grains reflecting light in a different way. And it's a very beautiful dune field bumping up against the hard rock of the mountains there. Over Central Africa, we saw a lot of burning going on. You can see several smoke plumes emanating from the rainforest area in Central Africa combined with the grasslands there. And this was one of the hot topics that we were looking for from space. We saw a lot of burning not only here, but also in Australia because it's the dry season there. A beautiful real-time sunset from Earth orbit. And now it's time for entry. We've got a small camera handheld in the cockpit that allows us to pan around and show you the orange-pink aerodynamic heating outside the front cockpit windows as we go through about Mach 15. Out the back windows, you can see the plasma tail trailing us behind as the hot plasma streams around the orbiter and goes back over the tail. It's a spectacular light show.
During that time where you saw the plasma trail behind us, we were tilted up at an angle of attack of about 40 degrees. Here we are looking out through a camera over the nose of the vehicle, and now the angle of attack is much lower and we're flying more like an airplane. It is dark overhead, so the only way to see us was with an infrared camera, and that's what you see in the upper right inset in this view. we continued to have the camera that's looking over the nose operate all the way to landing. And you see some lights on the ground, and you can see clearly why I called it a night landing. And just up towards the upper right and moving to center, you can see a dim outline of a long, thin light area, which is the runway. We are diving towards a set of lights about 1.5 miles short of the runway, which are lit up by strobe lights. And at about 2,000 feet, we start to pull out to shallow our steep dive angle, which is 18 degrees up to that point, to more of an airliner type glide slope so that we can land. At about 300 feet, Rommel put the landing gear down, and this is our view as we're finishing that pre-flare. On the left is a string of lights with a little ball next to it, which we're trying to line up and keep in the center so as to cross the runway at the right height at the threshold. And with the xenon lights providing the bright glow on each side of us, here's the touchdown viewed from the camera at the far end of the runway. You can see the vapor trails being turned up in the humid Florida air. At about 200 knots on the ground, Rommel deployed the drag chute, and at 185 knots we started the nose down to get all 3 wheels on the runway, and we'll start steering down, trying to stay on the center line of the runway because it's nothing more embarrassing than have the final photos of the vehicle not on the center line. It's also helpful to stay out of the mud and the weeds. And at about 60 knots, we release the drag chute so that it still has a good aerodynamic force on it, pulls it cleanly away from the vehicle so that it doesn't damage the engine bells. This is, after all, a reusable spacecraft. It was the 21st flight of Columbia, the 80th flight of the Space Shuttle program. And that is the end of our presentation. Thank you very much. And getting into and out of them is not real pleasant, so it was nice that we launched on the first day. It would have been, well, it was a reasonable trade to have to get in and out of the suit 2 or 3 times in order to get the extra couple days on orbit.
Launch day was absolutely a beautiful day, something new to me. On my last flight, I climbed in the vehicle several times before we went anywhere. Here the engines are lighting 6 seconds prior to liftoff. The vehicle stack goes through its twang, but when the solids
is working with Rommel to convert the computers over to on-orbit mode while we're getting ready in the back to check out the arm and get the satellite out of the bay.
We grappled the SPA satellite about 3.5 hours into the flight, and some checks were performed both by the crew and the ground. And here we are taking the satellite out of the payload bay and maneuvering to the release position. Tom, of course, is assisting me here with the arm.
While Columbia sat on the launch pad, the 5 of us were having breakfast and then getting suited up. Here I am waving to the kids. Rommel is just about to go through the pressure check of his launch and entry suit, and that's what Tammy is doing here as well. These suits are not totally uncomfortable, but they're not the kind of thing that you would like to wear, here's Tom, for any extended period of time.
While they're giving us about 6 million pounds of thrust at this point. At about 150,000 feet, they detach. We're going about 3,000 miles an hour here. And once they detach on the solids, it's a pretty rough, vibrant ride, and then it becomes a very smooth ride from there to orbit.
First order of business after getting to orbit is to convert our rocket ship into a laboratory or a satellite deployment platform in this case, and so we swing open the payload bay doors about 1.5 hours after getting to orbit. Taco.
Like this, there's no doubt in your mind you're going somewhere. We had a cadence. Tom started it. He said 102, 102. The computers were in mode 102. I said auto, auto. Pitch and roll yells were in auto and not CSS. And Taco was supposed to say, there goes the tower. But by the time he could say, there goes the tower had already gone. And we're doing more than 100 miles an hour at that point. Here are the solids. What's interesting, they've got 550 tons of propellant. And they're burning that propellant at the rate of about 5 tons per second. So that explains